Chapter 1, Section 5. This is Scientific Inquiry. So today we're going to talk about the types of measurements that we're going to do in this class and what units you're going to be using, as well as some information for the scientific method. So the first type of measurement is length. That's the distance from one point to another point. That's your definition. The unit that we're going to be talking about or using is the meter. So if I were to ask you to measure the length or the width of your piece of paper, I would hand you a ruler and you would probably use the side that has inches. Well, for this class and for any science class you use, we're actually going to use what are called SI units, okay? Those are a standard unit that all scientists use or that majority of the world uses for measurement. So that is the meter. And we're going to use a metric ruler. So instead of using the inches side of your ruler, we're just going to flip it around and we're going to use the centimeter side, okay? So again, length. Instead of using inches, we are using centimeters. So if you look at the image here, it's this bottom side, okay? So where you have everything that's really close together. Another type of measurement is volume, and that's the amount of space a substance occupies. And the base unit for that is liters, so like a liter Coke, or the cubic meter, and that's for a solid object, so meters to the third power. We can use a metric ruler if we're using a solid that's actually a regular solid, so a square or a rectangle, something that can be measured. Or if it's a liquid or an irregular solid, we can use a graduated cylinder. Okay, so if it's a liquid, we want to use a graduated cylinder or a beaker. Again, we can get length, width, and height if we want to get volume for a regular solid, that's a square or rectangle. And then if we want to do an object that doesn't have a specific rectangle or square shape, but is also not a liquid, we're going to use what's called displacement. So if you look at the image here, we have two graduated cylinders. This one is the before image, so before we add the object, there are 20, and this is usually in milliliters, so we have 20 milliliters of water, and then once we add the object, that number increases. The amount it increases by, that's the volume of your object. So this object went from 20 to what looks like 23. So this object has a volume of 3 milliliters. Okay, so let's look at an example really quickly. A student added a small ball to a graduated cylinder that contains 10 milliliters of water. What is the volume of the ball? A, 5 milliliters, B, 10 milliliters, C, 15 milliliters, or D, 20 milliliters. Now, I'm not going to give you the answer, but again, look at the height difference of the water. The difference between those two numbers, that's your answer. Okay, so go ahead and answer that in your notes for today, and we'll go back and look at that later. Another thing that we're going to be measuring is mass. It's the amount of matter in a substance. We're going to use grams or kilograms for that. Okay, and we'll use triple beam balances or digital scale. Majority of class you will be using triple beam balances. We'll do some experiment with those. That way you get used to them. So we have a digital scale here. You can see that picture. And then, of course, we have the triple beam balance, which is exactly what you're going to be using up here at the top. Okay, another thing that we're going to be looking at in this class is weight. And weight is a measure of a gravitational force acting on an object. So when I say weight, you're probably thinking of pounds, right? Well, weight is actually not in pounds. Weight, because it is a force, is measured in newtons. Okay? And you'll see this in physical science or physics if you decide to take one of those two. But we will use newtons for weight, okay? And that's the effect of gravity or of Earth pulling us toward the core. Okay? And we are going to use scales for this. So think about your bathroom scale, or maybe the scale at the doctor's office, or even the scale at the grocery store. Okay, those are calibrated or set to where they're actually measuring not necessarily your pounds, but your weight in what we consider to be newtons. Okay. So for example, if we talk about mass versus weight, the astronaut has a mass of 120 kilograms. Well, on the Earth, his weight would be 1,200 newtons. Whereas if he went to the moon, his weight would change because the force of gravity is different on the moon than here on Earth. Okay, mass stays the same, but weight will change based on the gravitational force affecting you. Another thing that we're going to be looking at is time, so how long it takes for an event to occur, and we are going to use seconds, so that's nothing new. But if you are given something that's in minutes or hours, you will need to be able to change that to seconds. And what we're going to look at is the clock and the stopwatch. Okay? So we will be doing some experiments where you'll have to time some things, and we'll be using stopwatches for that. Another thing is temperature, and that's the amount of kinetic energy a substance has. And the unit for temperature is actually Kelvin. Kelvin is a little bit more difficult to understand. It's represented by a capital K. Majority of this class we're going to use Celsius instead. But what do we all know that we use here? Fahrenheit, right? So what we're going to use is the thermometer. You guys all know what a thermometer is, right? But instead of using the Fahrenheit side, we are actually going to use Celsius. So looking at a comparison between what Fahrenheit, Celsius, and Kelvin are, here's an example. So water freezes at 32 degrees Fahrenheit for us, okay? But in Celsius, that is 0 degrees Celsius, okay? And then if we move on to Kelvin, it's 273.15, okay? The boiling point of water, 212 degrees Fahrenheit. That's 100 degrees Celsius. Can you see how Celsius is kind of an easier system to use? It's kind of 100 is a nice number, 0 is a nice number. And then absolute zero, which is the absolute coldest temperature that it can reach, that's negative 460 degrees Fahrenheit, or negative 273 degrees Celsius, or 0 Kelvin. So Kelvin scale bottoms out at 0. There are no negative numbers. Okay? So keep that in mind. Another thing is density. It's how compacted the matter is in a substance. So we're talking about the mass of it and the volume. Okay? So you would have your mass over your unit of volume. So grams per milliliter, grams per centimeter cubed, kilograms per meter cubed. All of those can be units for density. But you need to look at what units you were given in order to know what unit to use. So if I give you grams and I give you meters cubed, well, then it should be grams per meters cubed. Okay. Density is what we call a derived unit because it's made up of more than one type of measurement. So we have mass and volume. And so what we have is a formula that goes with density. So D equals M, mass, divided by volume. Okay. Now, objects will float if their density is less than the density of the fluid they're in. So, for example, for water has a density of about 1.0. So anything with a density of less than 1.0 should float in water. Okay. Now, when I say fluid, that could be a liquid or a gas. Okay. So it could be water. It could be in the atmosphere. So think about things that float in the atmosphere. And we'll do an example or an experiment with density. So for today, I need you to read 1.2 and 1.3 from your environmental book. Okay. And then you'll need to work on lesson 4 handout. Your metric and your density lab is due today. So if you haven't finished that, you will need to go ahead and finish that at one of the lab tables. And then tomorrow we will do chapter 1, section 3. And we'll do lesson 5 handout, and your lesson 4 handout will actually be due tomorrow if you do not finish it in class today. Okay, and that's it for today.